In this video, we will guide you through interfacing an ultrasonic sensor with an Arduino to create a water level monitoring system. We will start by introducing the components needed: an Arduino board, an HC SR04 ultrasonic sensor, a breadboard, and some jumper wires. We will then show you how to connect the ultrasonic sensor to the Arduino, write the necessary code to measure the water level and display the readings. By the end of this tutorial, you will have a fully functional water level monitoring system that you can use for various applications such as water tanks, reservoirs, or any container where monitoring the water level is essential. Let's dive in and build this project together.
In this code, we are going to connect your ultrasonic sensor. In your ultrasonic sensor, there will be two concepts. One is trigger and another one is echo. From the trigger, the ultrasonic ray is going to pass and the corresponding sound falls on the object or any wall. It automatically is going to reflect. That returned ultrasonic sound is going to capture by the help of your echo. So with the help of this concept, we are going to find the time interval. That time interval will help to predict the distance from the sensor towards the object. So that type of distance can be predicted with the help of this ultrasonic sensor. So here, to connect the trigger pin, we have assigned as a digital pin 9, and for the echo pin, we have assigned a number as 13, and here we have connected a 13 pin towards our LED, and then setup. So inside the setup, we have started our serial begin 9600. This serial begin is going to be a screen for your output display. That means your serial monitor. With the help of the serial monitor, you can check what are the output we have got from the implementation. So that output can be printed towards this serial monitor. And then here, but initially the trigger point will be in output and your echo pin will be in input constant. So first of all, the trigger pin is going to be a high, and after that, when the trigger pin goes towards your low, at that time the echo pin going to predict what about the time interval have been captured with the help of this pulse in keyboard. This is the formula to convert your time interval into a distance. Here we have predicted a distance in a centimeter. That details have been printed towards a serial monitor with the help of the serial.print. Here we have predicted that if the value is below 10, that if you find the distance centimeters below 10 means at a time the corresponding LED will low to high, and in a serial monitor the water level reached below message will be printed. If the value is above 10 means the corresponding LED will stop to glow. So this is the coding we have implemented here. Now we are going to upload this coding towards your Arduino. Before that, we are going to connect our Arduino. We are going to connect our ultrasonic sensor with the Arduino. So this is the ultrasonic sensor. There will be a 4 pins: VCC, trigger, echo, ground. The VCC pin will be connected with the Arduino 5 voltage, and then trigger. Here we have declared the pin as 9 in your coding. So this trigger pin will be connected with the pin number 9, and then echo 10, and at last your ground, it's going to connect with the ground of your Arduino. So this is the connection for connecting ultrasonic sensor with the Arduino, and also we are going to connect the LED with the 13 pin number. So now you can upload and check our output. You can click your upload arrow to upload your coding to your Arduino. After completing your compilation, this code will upload towards your Arduino. So now we have uploaded. In your Arduino IDE, before the close button there will be a serial monitor. Just click it out. You can check out the centimeter you have predicted here. So whenever you try to disturb your ultrasonic sensor, the value will came below 10 centimeter. At the time the condition will be okay, and then the water level reached message will be printed in your serial monitor. At the same time, your LED will automatically go to high. Whenever the distance goes below 10, this if condition will be executed and the corresponding output can be predicted.